Alright, here is the video notes for section 7.1, complex numbers. We're going to talk about some basic definitions today. So all about imaginary numbers. So we've kind of talked about this a little bit. Imaginary numbers, that's when we take the square root of a negative 1. Well, we can't do that. So we say that this, by definition, is equal to our imaginary number, or our imaginary unit I. Your textbook uses J instead. They use that because it's kind of a technical course, and so I guess is used for electric current as a variable for that. So the textbook uses J, but your final and any other future math class that you take, they use I. So I'd like you guys to get in the habit of using I. Your homework is out of the textbook though and uses J, so you're not going to get taken off points if you use J. But just for this section and anything dealing with complex numbers, just know that if it's J, it really means I. And get in the habit of using that I. So here's some examples here we'll work through. So the first one you see, we've got the square root of negative 9. What that means is we can rewrite this as the square root of the square root of 9 times negative 1. We know that the square root of 9 is 3. So we've kind of got here 3 times the square root of negative 1, which is I, so 3i. Let's look down here at letter B. We got the square root of negative 0.25. So 0.25 is perfect square. So we have 0.25. We're looking for the square root of 0.25 times negative 1. Square root of 0.25 in your calculator is going to give you 0.5. And then 0.5 times I. Now letter C, square root of negative 5. 5 is not a perfect square. So when we write this out, there's not a whole lot we can do, except rewrite it like this. However, not like that. Flip that around. The 5 has to stay under the radical, which means that negative 1, that square root of negative 1 is I, bring it out front. We like that to be I times the square root of 5. Now, something to be careful about. So the square root of negative 4 squared, this is not the same thing as the square root of negative 4 times negative 4. Because when we work that out, the square root of negative 4 times the square root of negative 4, this would then become the square root of positive 16, which is 4. However, if we looked at it in terms of I first, with the original question, so square root of negative 4, let's do it this way, times the square root of negative 4. So we see here that that is 2i times 2i. So we can multiply our 2 times 2, which is 4. The I times I gives us I squared, which we'll get to the I squared example in a little bit. But basically I squared is going to be negative 1. So this would give us negative 4 is what that would simplify to. But negative 4 is not the same as that positive 4 up there. So be careful with simplifying. Basically, you're going to put things, whenever you see radicals with I, your square root of negative 1, you're going to put it into I terms first. So, break that down, put it in I first, and then simplify. So let's look at this example 3, where we are going to break this down and put it in I first, because you see that the square root of negative 3 times the square root of negative 12 is not the same as the square root of negative 3 times negative 12. So let's break it down into terms of I first. So if we look at that first one, negative square root of negative 3, we can break this down. We know that that's going to be I times radical 3. And then the square root of negative 12 is the same as, well, 12 is not a perfect square, but 4 is. So we can break that down into the square root of 3 times 4 times negative 1. 4 comes out as 2, Negative 1 comes out as I, so it's going to be 2I radical 3. So now times them together. So I radical 3 times 2I radical 3. So you kind of rearrange the terms. You've got 2I squared there, radical 3 times radical 3, which we know we'll just simplify down to 3. And then that 3 will get multiplied by the 2 at the beginning, so our final answer will be 6I squared, which is just negative 6. It's kind of a fun one. So, put things in terms of I is what it's called first. Express the number in terms of I. Like you see how this, by definition, the square root of negative a is going to be I times the square root of a, where a is positive, so a cannot be 0. So let's express some of these in terms of I. Looking at letter A, we got the square root of negative 6, which we can break down into square root of 6 times negative 1. Square root of 6 isn't perfect, so it stays under there, but the negative 1 becomes I, so I radical 6. And then let's look at letter B, negative square root of negative 75. So the negative stays on the outside. 75 is not perfect, but we know that breaks up into 25 times 3 times negative 1. So the 25 becomes 5. Negative 1 comes out as I, so radical 3 is left under the radical. Alright, so powers of I. These ones are kind of fun. We know that I, so I to the first power, is the square root of negative 1. But I squared, take a look here, we make that square root of negative 1 times the square root of negative 1. Square root's going to just cancel out, and it's just going to be positive 1, or negative 1. So I squared is equal to negative 1. I cubed then, and now that's just I squared times I, so that's going to be negative 1 times I, or just negative I. I to the fourth is where it gets fun, because I to the fourth, we can rewrite that as I squared times I squared. We know I squared is negative 1, so I to the fourth is now negative 1 times negative 1, or 1. So any I to the fourth power is just going to be 1. So when you see things like I to the fifth here, you want to break it down to where you have a 4 in there. So this I to the fifth would break down into I4 times I to the first. I to the fourth we know is 1, so pretty much that just cancels. So I to the fifth is the same thing as I. And it kind of repeats that pattern. So I to the 6 is going, if I to the fifth was I to the 6 is going to be the same thing as, I to the 6 is going to be the same thing as I squared, so it's just going to be negative 1. Where I to the 7th is going to be the same as I cubed, so it's going to be negative I. And I to the 8th is going to be the same as I to the 4th, which is 1. Here's a hint. You're looking for i's that are factors of 4. The exponent is a factor of 4. Because whenever your exponent of I is a factor of 4, it's going to break down to just 1. Let's do some examples of this. So here we have I to the 10th. So 4 can go into that 2 full times, right? So that would give you 2 full times would be I to the 8th, with then 2 left over. So you want to rewrite that I to the 10th as I to the 8th times I squared. Because I to the 8th we know is 1, so that is just 1 times I squared, which is negative 1. So this just breaks down to negative 1. Look at I to the 45. So the biggest factor of 4 that goes into 45 is 44. So I to the 44 we'd have 1 left over. I to the 44 times I to the 44 is just 1. 1 times I makes this just I. Now look at C. This one is where it gets a little bit tricky. I to the 531. So now, you want to break it down so you have a factor of 4. So what I do, and I pull out my calculator for this, I do 531 divided by 4, which that gives us 132.75. We don't even care about that 0.75. We care about that 132 because we know 132 times 4, let's see, that's 528. So then, that means, let me rewrite this. We can rewrite this I to the 531 as I to the 528. And then we've got 3 left over to get to 531. So it's going to be I to the 528 times I cubed. And I to the 528, that's just 1. I cubed is negative I. So our answer here, ignore that, our answer here is just going to be negative I. These ones are kind of fun. Alright, so a little bit of vocab. Complex numbers. These are numbers that are kind of in this form. A plus B I. The imaginary part, make sure I have this right. The imaginary part is B. The, kind of skip down here. The real part is A. So imaginary part is B. Real part is A, or BI, I guess, is the imaginary part. This format is just kind of that rectangular format too. So complex numbers kind of always have this rectangular form. If it's pure imaginary, it's just BI. So A in this case would be 0. It would be something like, let's say we had 2I. That would be a pure imaginary. But if it's in that rectangular format, it's something like 3 plus 2I. So in this case, the real part would be 3, and the imaginary part would be 2I. We also have conjugates. So conjugates, you're just changing the sign in the middle there. You're making it so that it is the real part plus or minus the imaginary part. And it's that plus or minus the imaginary part that is the part that's important. So if we look at letter A, we're just changing the sign. This one's easy. So the 3 plus 2I. Letter B, we're also changing the sign, but the sign that we're changing is not the negative 2. It's that middle sign. It's that plus 5. Now, I said we're only changing the sign for the imaginary part. C is only imaginary. So 6I, the conjugate of that will be negative 6I, because you change the sign on the imaginary part. And then D doesn't have an imaginary part, it's just the real part. So the conjugate is that is just 3. So the thing to remember here is that we change the sign of the imaginary part only. Alright, so we change the sign of the imaginary part only. So your homework is going to be 5 through 51 odds. Yes, that's a lot, but I think a lot of them will go quickly. And since I'm not doing instruction all day tomorrow, you've got like the whole day after you see this to do that. So we literally only had like 15 minutes of instruction. You have the rest of the time to work on homework. So that's a lot of extra time. You guys can do this. Thank you.